Hello, my name is Ardi and we are going to solve problem E3.14. So the question is find V0 in this figure here, figure E3.14 using mesh analysis. Because we are going to use mesh analysis, let's draw the loop here. Let's draw this loop here as loop I1. And then this loop here as I2. And this loop here as I3. Good. Now let's start with using KVL at loop I1. KVL at loop I1. KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's start from this 10-volt voltage source, and the current is flowing from the negative terminal to positive terminal, so our sign will be negative, minus 10. And then we will move on to this 2 kilo ohm resistor, so we'll have 2, but this is resistor, so we need to convert it into voltage by multiplying the current. And the only current that pass through it is I1, so I will have 2 I1 here. And now let's move on to this 3 kilo ohm resistor, so we'll have 3, and the only current that pass through it is also I1. Good. Now let's do this 4 kilo ohm resistor, but there are two currents that pass through it. I1 is going down, I2 is going up. But here we are working on loop I1, so we will multiply it by I1 first, and then I2 is going to the opposite direction, so we'll have minus I2. Good. And now this one will be 3 kilo ohm. Again, we multiply it by I1 first. But here I3 is flowing to the opposite direction, so I will have minus I3. Good. And the last component is this 8-volt voltage source, so we will have plus 8 because the current is going from the positive terminal to negative terminal, so I will have plus 8. Good. All of that will equal to 0. Now let's do some simplification. For I1, we will have 2 plus 3, that will be 5. 5 plus 4, that will be 9. And then 9 plus 3, that will be 12. Okay, I think that is good. So we'll have 12 I1. I2 only comes from here, but we have 4 of them, so I will have minus 4 I2. And then minus 3 I3. That is only came from here, right? So we'll have minus 3 I3. Minus 10 plus 8 is minus 2, but then we move it to the right hand side, so this will equal to 2. I think nothing further that we can do from here. Let's save this as equation number 1. Okay, that is good. And now let's do another KVL, but this time at loop I2. KVL at loop I2. Again, KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's start from this 4 kilo ohm resistor. So we'll have 4. But now we are working on I2. So this time I2 came first. But here I1 is flowing to the opposite direction. So I subtract I1 from it. Okay, and then let's move on to this resistor here. So we'll have 4. And the only current that pass through it is I2. Good. And then we have a voltage source, and the sign will be negative because the current is going into the negative terminal. So we'll have minus, and the magnitude will be 12. Good. And then the last component will be that 6 kilo ohm resistor. Again, we are working on I2, so I2 came first. But here, I3 is flowing to the opposite direction. I2 goes to the left, I3 goes to the right, right? So we will have I2 minus I3. Good. And then all of that will equal to 0. Okay, now let's do some simplification. I1 only comes from here, so we'll have minus 4I1. And then I2 will comes from 3 places, 4 plus 4, and then plus 6. We will have 14 I2. and I3 only comes from here, so we will have minus 6I3. And the constant term here, minus 12, is only came from here. Let's move that to the right hand side. So we'll have that will equal to 12. Okay, now let's set this as equation number 2. And then let's do another KVL, but this time at loop I3. KVL at loop I3. KVL said that the sum of the voltage in a loop will equal to 0. Good. Now, the current is flowing from the negative terminal to positive terminal, so our sign will be negative. So we'll have minus 8, and then we will have plus. We'll have 3 kilo ohm. And now we are working on I3, so we'll have I3 here, then minus I1. Good. And then we will have plus 6 kilo ohm. So we'll have I3. And then here I2 is flowing to the opposite direction. So we'll have minus I2. And then the last component will be this 6 kilo ohm. So we'll have 6 I3. All of that will equal to 0. Good. Now we will have to do some simplification. I1 only comes from this place here, so we'll have minus 3 I1. I2 only comes from here, so we'll have minus 6 I2. And then I3 comes from 3 places, 3, 6, and 6. So we'll have 12 plus 3, that will be 15. So we'll have plus 15 I3. And then let's move this minus 8 to the right hand side, so we'll have 8 here. And this is equation number 3. So now we have 3 equations with 3 variables. We can solve this, right, using linear system equation. And the fastest way to do it is just by using calculator. So let's reset our calculator first. Okay, and how to set up as equation solver? This button here, and equation solver is number 5, 3 variables is number 2. Okay, so we'll have the first equation. Let's plug the coefficients. So we'll have 12, and then minus 4, and then minus 3. Okay, and then the constant term is 2. Good. And then for the second equation, we will have minus 4, and then 14, and then minus 6. And then the constant term is 12. Good. And for the third equation, we will have minus 3, minus 6, and then 15, and that will equal to 8. Okay, so we'll have P1 here, which is 1.148. Okay, let's use another color here. So I will have I1 is equal to 1.148. 1.148. And the unit will be in milliampere because this is in volt and kilo ohm. So we'll have milliampere here. And what is I2? I2 is the Y value, so I'll have 1.825. 1.825, and the unit here is milliampere. And then what is I3? I3 is the Z value, which is 1.493. 1.493 milliampere. However, the question does not ask about I1, I2, and I3, but it is asked for V0. And we can calculate that using Ohm's law, right? Because V0 is just I3. The only current that passes through it is I3. Then multiplied by the resistance, which is 6. Okay, so we will have 1.493 multiplied by 6. And so we will have V0 is, okay, let's calculate this. 1.493 multiplied by 6. So we'll have 8.96, 8.96, and the unit will be in volt. And this is our final answer for this question. And I think that is correct because that is exactly the answer given by the book. Okay, thank you for watching. See you in the next video. Bye-bye.